So good morning all. Today we are going to discuss about chemical bonding and the different types of chemical bond. So before going to the chapter, we know that we can see a large number of substance around us. That is, we can see large number of substance in our surroundings, and all the substance they are made up of molecules, and the molecules in turn they are made up of atoms. So all the substance are made up of molecules, and the molecules in turn it is made up of atoms. We have already studied that the atoms they combine to form molecules in order to attain stability. So atoms combine to form molecules in order to attain stability. So if we are considering two atoms, neon and chlorine, we know that the atomic number of neon it is 10 and the electronic configuration is 28, and in case of chlorine the atomic number of chlorine is 17 and the electronic configuration is 287. So if we are considering the outermost shell of neon, we can see that the outermost shell of neon contains 8 electrons. That is 1, 2, 3, 4, 5, 6, 7, 8. The outermost shell of neon contains 8 electrons. And if we are considering chlorine, the outermost shell of chlorine, it contains 7 electrons. That is 1, 2, 3, 4, 5, 6 and 7. So the outermost shell of neon contains 8 electrons and the outermost shell of chlorine it contains only 7 electrons. So if we are considering neon, we know that the neon it belongs to the noble gas. So it belongs to noble gas. So the group 18 elements in the periodic table, they are known as noble gases. That is helium, neon, argon, krypton, xenon, radon. They all belong to the noble gas configuration. That is, they are stable. The atoms, that is helium, neon, argon, krypton, xenon, radon, they are stable and they do not participate in the chemical reactions because they are stable. As they are stable, they do not participate in the chemical reaction. So in case of neon, it is stable because it has 8 electrons in the outermost shell, and in case of chlorine only have 7 electrons in its outermost shell. So the arrangement of 8 electrons in the outermost shell of an atom is known as octet electronic configuration. The arrangement of 8 electrons in the outermost shell of an atom, it is known as octet electronic configuration. So if we are considering all the noble gases, we can see that if in case of helium only 2 electrons is present, but in case of a helium, there are 2 electrons in the outermost shell. In case of neon, it is 8 electrons. Argon, it is 8 electrons. Krypton, it is 8 electrons. Xenon, it is 8 electrons. And radon, it is 8 electrons. And if we are considering the electronic configuration also, all this the atoms, they contain 8 electrons except helium in the outermost shell. As helium is having the atomic number 2, it can only have 2 electrons and it is stable. So all the noble gases, they have 8 electrons except helium in the outermost shell, and they are stable and they do not participate in the chemical reactions. And the arrangement of 8 electrons in the outermost shell of an atom, it is known as octet electronic configuration. So hope you understand what is octet electronic configuration. That is arrangement of 8 electrons in the outermost shell of an atom. It is known as octet electronic configuration. And all the noble gas except helium have 8 electrons in its outermost shell, and the noble gases, they are stable and they do not combine to form molecules or they do not participate in the chemical reactions. So we know that, so now we have already studied that the atoms they combine to form molecules in order to attain stability. So the attractive force that holds the atoms together in a molecule is known as chemical bonding. So except noble gas, all other atoms, they participate in the chemical reactions or chemical bonding in order to attain stability. So all the atoms they try to attain a octet electronic configuration in the outermost shell in order to become stable. All the atoms they try to be stable, and for that they combine they combine with other atoms, or they will combine with sometimes the same atoms in order to attain the stability. And the main aim of all these atoms, it is to attain a octet different electronic configuration, and for that they will participate in different chemical reactions, and the attractive force that hold the atoms together in a molecule, it is known as chemical bonding. So chemical bonding is the attractive force that holds together the atoms in a molecule. It is the chemical bonding. So now we are going to study about the different type of chemical. So in case of chlorine, it has 7 electrons in the outermost shell. So for sodium, it has two options. Either it can lose one electron in order to become a configuration of 2 8, or it have to attain 7 electrons so that it can become 2 8 7. So sodium, it has two options, that is either it can release or lose 1 electrons and become a configuration of 2 8, or it have to attain 7 electrons and to become a configuration of 2 8 8. So in case of chlorine, also chlorine has 7 electrons in its outermost shell, and so in order to attain stability, either chlorine have to lose 7 electrons so that it can become the configuration of 2 8, or it have to gain 1 electron in order to attain the configuration 281. So it is clearly understandable that for chlorine it is more easier to gain 1 electron so that it can become a configuration of 288, and in case of sodium, it is easier for the sodium to release 1 electron or to lose 1 electron so that it can become a configuration of 28. So what is happening in the case of sodium and chloride is that here sodium with configuration 281, sodium is giving its 1 electron. So it is clearly visible that sodium is giving its 1 electron to chlorine, and chlorine is attaining that 1 electron. That is, sodium loses 1 electrons and it become a configuration of 2 8, and in case of chlorine is accepting that 1 electron and it is becoming a configuration of 288. So in both the cases, chlorine and sodium and chlorine, they both they attain a 8 electron configuration, also or a noble gas configuration, so they both are stable. So the combination of sodium atom and chlorine atom in order to form sodium chloride is known as so they form sodium chloride. That is, the one sodium atom, it loses 1 electron, that is, it gives its 1 electron to chloride ion and it become a sodium ion. And in case of chlorine atom accept 1 electron from sodium. Chlorine atom accept 1 electron from sodium and it become chloride ion. So sodium atom, when it loses 1 electron, it becomes sodium ion, and when chlorine atom, it gains, or when it attains 1 electron from sodium, it has become a chloride ion. So we can draw the electron dot structure of sodium and chlorine. So electron dot structure means the representation of only the outermost valence electrons. So that's only the number of electrons in the outermost shell is represented in in the Lewis diagram or in the dot diagram. So we know that in case of sodium has 281. It is the electronic configuration of sodium and it has 1 electron in the outermost shell. So the 1 electron is represented here, and in case of chlorine, it has 7 electrons in its outermost shell. So it's the 7 electrons, it is represented as dot in this case. So here, when sodium and chlorine, they combine with each other, the sodium, it loses 1 electrons and it will become a sodium ion. As it loses 1 electron, it gains a positive charge. Sodium loses 1 electron, so it it attains a positive charge. And in case of chlorine, the chlorine gains 1 electron, so it has become, so the outermost configuration of chlorine will become 8, and as it accept 1 electron, a negative charge is represented there. So as sodium loses 1 electron, it has become a sodium ion, and chlorine atom gains 1 electron, it attains a negative charge and it will become a chloride ion. So the positive charge, it is known as cation, that is the ion, that is sodium ion, or either any ions with a positive charge is known as cation. In any ion with a positive charge is known as cation, and in the ion with the negative charge is known as anion. So in case of sodium, in the formation of sodium chloride, sodium it has only one electron in the outermost shell, and chlorine, it has seven electrons in its outermost shell. So when they combine each other, sodium chloride is formed. As one electrons of sodium is transferred to chlorine, sodium will gain a positive charge and chlorine will gain a negative charge with 8 electrons. So it is a representation we can make from this. So the ions with the positive charge is known as cation, and those with the negative is known as anion. So here again, the representation of the formation of sodium chloride, that the sodium has 8 electrons. 281 is the configuration. Sodium, it transfers the 1 electron in the outermost shell to chlorine. So sodium becomes Na plus and chlorine becomes Cl minus. The chemical bond which is formed by the transfer of electrons are known as ionic bond. So these type of bond is known as ionic bond. That is, here a transfer of electrons has been taken place. That is, sodium transfer the one electron from its outermost shell to the outermost shell of chlorine. So the chemical bond formed by the transfer of electrons, it is known as ionic bond. And these ions, the ions, they are held together in ionic bond by electrostatic force of attraction. So it is electrostatic force of attraction, that is, that act between the oppositely charged ions. So these ions are held together by the electrostatic force of attraction between the oppositely charged ions. So hope this idea is clear. That is, in case of sodium atom, the attractive force that holds together the atoms is known as chemical bonding. And in case of sodium atom, the outermost configuration is 281, and the chlorine, it is 287. So in order to attain stability, sodium has two options: either it has to lose one electron or it has to gain 7 electrons. So it is easier for chlorine to sodium to lose one electron and become octet configuration of 28, and in case of chlorine, 287 is electronic configuration of chlorine, and it is easier for the chlorine to attain one electron. So there is a transfer of electrons takes place between sodium and chloride. Sodium transfer one electron to chlorine, and and it is shown here. So the sodium will be attaining a positive charge, and the positively charged ions are known as cations, and chloride will be getting a negative charge, and the negatively charged ions are known as anions. The chemical bond formed by the transfer of electrons, which is known as ionic bond, and the ionic bond, they are held together by the electrostatic force of attraction between the oppositely charged ions. Okay, so that is the first type of chemical bond, that is ionic bond. And if we are considering another atom, that is fluorine, we know that the outermost shell configuration, the electronic configuration of fluorine is 27. The atomic number is 9, and fluorine is having 7 electrons in its outermost shell. So fluorine is having 7 electrons in its outermost shell. So in order to attain stability, either fluorine has to lose the 7 electrons or fluorine has to gain 1 electron. So either fluorine has to lose 7 electrons or it has to gain 1 electron. So in case of fluorine, a special kind of sharing is taking place. That is, it is not the transfer of electrons as in case of ionic bond. Two fluorine atoms, they came together and they share electrons. That is, in case of fluorine, one fluorine atom, it is having 7 electrons, 1 2 3 4 5 6 and 7 electrons in the outermost shell. And when another fluorine atoms combine with them, when another fluorine atoms, they come and combine with them, one pair of electrons is being shared there. One pair of electrons is being shared there. That is, so in case of fluorine, 7 electrons is having in the fluorine has 7 electrons in the outermost shell. That is, one fluorine is having 7 electrons. That is 1 2 3 4 5 6 7 electrons in its outermost shell. One fluorine atom is having, okay, the representation, one fluorine is having 7 electrons in the outermost shell. So and if consider two colors, that is just for example, just assume that one fluorine atom is having black and another is having red, and the atoms, that is, the atoms can be represented by 7 electrons in the outermost shell. One fluorine is having 7 electrons, and this fluorine is also having 7 electrons. So in order to attain stability, the electrons are being shared. The electrons are being shared in this case. That is, one fluorine atom is having 7 electrons. That is 1, 2, 3, 4, 5, 6 and 7. In case of another fluorine atoms also same case 1, 2, 3, 4, 5, 6, 7 is. So this fluorine atoms shares the sharing is taking place. That is, now if you are looking at the configuration, both the fluorine atoms will be having inside the circle there will be 8 electrons. That's 1, 2, 3, 4, 5, 6, 7. That is, for both fluorine atoms there will be 8 electrons, and we can say that now they had attained stability. So here a sharing of electrons takes place. It is not the transfer of electrons here taking place, it is a sharing of electrons taking place. So the chemical bond formed as a result of sharing of electrons between the combining atoms, it is known as covalent bond. So covalent bond means that it is a chemical bond which is formed as a result of sharing of electrons. Here the electrons, they are shared between each other. So the chemical bond formed as a result of sharing of electrons between the combining atoms, it is known as covalent bond. So in covalent bond, and what is happening, electrons are shared, they are not transferred, they are shared. So in this fluorine atoms also, when two fluorine atoms they came together, they share the electrons, they share the one electron in the outermost shell between each other, and as a result of that a covalent bond is being formed. So in case of fluorine molecule, so when two fluorine atoms they came together, it is known as fluorine molecule. So in case of fluorine molecule, only one pair of electrons is being shared. One pair of electrons is being shared. We can say that one pair of electrons is being shared, and the covalent bond which is formed by the sharing of one pair of electrons is known as single bond. So single bond means only one pair of electrons, that is two electrons are shared, and the covalent bond which is formed by the sharing of one pair of electrons is known as a single bond. So covalent bond is formed by the sharing of electrons, and the covalent bond which is formed by the sharing of one pair of electrons between the combining atoms, it is known as a single bond. So now we can consider another atom, oxygen. So oxygen, the electronic configuration of oxygen is 2,6. That is, oxygen atom, one oxygen atom need two electrons in order to attain stability. So in order to attain stability, the oxygen atom, what needs, the oxygen atom need two electrons. One oxygen atom needs two electrons. So one oxygen atom is having 6 electrons in its outermost shell. Another oxygen atom is also having 6 electrons in its outermost shell. So if these combine each other, so both the oxygen atom, they can share the electrons. The oxygen atom can share the electrons. So by on sharing the electrons, to sharing two pair of electrons, they will attain stability. So if we are considering one circle, we can see if we are considering this circle, we can see that there is 8 electrons in the outermost shell of an oxygen, and in other oxygen atom also there is 8 electrons. So in case of oxygen atom, there are 6 electrons in the outermost shell, and when two oxygen atom they combine each other, they share two pairs of electrons in order to attain stability, or in order to attain a octet configuration. That is, we can clearly see in that in case of oxygen molecule, two pairs of electrons are shared. Two pairs of electrons are shared, and the covalent bond formed by the sharing of two pairs of electrons is known as double bond. So double bond means the covalent bond which is formed by the sharing of two pairs of electrons is known as covalent bond. So it is known as, double bond. Okay. So in the case of nitrogen, nitrogen is having 5 electrons in the outermost shell. So nitrogen is having 5 electrons in the outermost shell. That is nitrogen 1, 2, 3, 4, 5 in its outermost shell, and when it combined with another nitrogen atom, it is also having 5 electrons. So it can combine with each other to get an octet electronic configuration. So we can say that. So in the case of nitrogen molecule, 3 pairs of electrons are being shared, and the covalent bond which is formed by sharing of 3 pairs of electrons is known as triple bond. So here 3 pairs of electrons are shared in order to get a octet electronic configuration, and the covalent bond which is formed by the sharing of 3 pairs of electrons is known as a triple bond. So in case of nitrogen atom, two nitrogen atoms they combine to each other to form a nitrogen molecule, and in case of nitrogen molecule, 3 pairs of electrons are shared, and the covalent bond which is formed by sharing of 3 pairs of electrons is known as a triple bond. So we have discussed about two types of chemical bond that is ionic bond and covalent bond. In case of covalent bond, the chemical bond which is formed as a result of sharing of electrons between the combining atoms, it is known as covalent bond. So in case of fluorine also, fluorine is having a outermost configuration of 2,7, that is it need one more electron in order to attain a stable gas configuration. To two fluorine atoms, they combine with each other to form a fluorine molecule, and here one pair of electrons is being shared. And in case of fluorine, the covalent bond formed by the sharing of one pair of electron, it is known as single bond. In case of oxygen, the configuration is 2 6, and oxygen needs two more electrons to attain stability. So they combine two oxygen atoms, they combine each other and share two pairs of electrons, and the covalent bond which is formed by sharing of two pairs of electrons is known as a double bond. And in case of nitrogen, nitrogen is having 5 electrons. So in order to attain stability, nitrogen needs 3 more electrons. So two nitrogen atoms they combine to each other to form a nitrogen molecule, and the covalent bond which is formed by sharing of three pairs of electrons is known as triple bond. So ionic bond means we know that the atoms they combine to form the atoms combine to form molecules in order to attain stability. That is, they all the atoms they try to attain a octet electronic configuration. The noble gas they already have the octet electronic configuration, and they do not participate in the chemical reactions. The arrangement of 8 electrons in the outermost shell of an atom is known as octet electronic configuration, and the attractive force that holds together the atoms in a molecule is called the chemical bonding. And in case of sodium and chlorine, in order to attain stability, sodium needs in sodium either sodium have to lose one electron or it has to gain 7 electrons. So it is more easier for the sodium to lose one electron. And in case of chlorine, in order to attain stability, chlorine can except one electron. So a electron transfer takes place between the sodium and chloride. That is, a sodium it gives one electron in its outermost shell to chlorine. So that sodium so in order to attain stability, electron transfer takes place here. Sodium gives one electron to chlorine. So sodium becomes an electronic configuration of 2 8, and so chlorine becomes 2 8 8. And after transferring one electrons, sodium atom becomes sodium ion with a positive charge, and these positive charged ions are known as cations. And chlorine atom become chloride ion, and it gains a negative charge, and the negatively charged ions are known as anions. So in the case of sodium chloride, sodium is the cation and chloride is the anion. So the chemical bond which is formed with the transfer of electrons is known as ionic bond, and the chemical bond which is formed by the sharing of electrons is known as covalent bond. There are three type of covalent bond: single bond, double bond and triple bond. Single bond means the covalent bond which is formed by the sharing of one pair of electrons is known as a single bond. Example is fluorine molecule. And double bond means the two pairs of electrons are being shared, and the example is oxygen molecule. And in case of nitrogen molecule, three pairs of electrons are being shared, and the covalent bond which is formed by sharing of three pairs of electrons is known as a triple bond. Okay, so hope you all understand. Thank you.